You know, sometimes they were using it to measure things that we kind of knew, but we're able to measure them more accurately. Sometimes you get surprises, and what you thought you knew was actually the total opposite. And those are the really exciting things to a scientist. And, hey, we thought we had this figured out, and we totally don't, and that's exciting.
All right, Paul, we're talking about the future of golf club tech, and in my hands I have a Ping i2 driver. Now this is, if you don't know, this is made of laminated maple. It has heel-toe balance. I know that because it says it on the toe, and it has some metal screws in the sole plate. How were you ever able to improve on technology to get the G430 driver?
Well, you know, it's been tough, but with a big team, we've worked on a few things over the last 30 years. It's amazing how much technology was packed into that for the time, right? And you can look at it now and we can laugh at it, but it was pretty cool for its time.
Yeah, no, this was the driver to have.
Forward. I mean, you know, this thing is hollow titanium. It's got about 6 different materials in it. Just what we can do with the manufacturing, what our tools enable us to do. Carsten would have had a field day with it, right? You imagine, you know, imagine how much fun he'd have had with the tools we have at our disposal now.
Yeah. So what do you think was maybe the biggest manufacturing change between, say, this the maple driver and that 430, or just that progression?
I mean, honestly, I think a huge thing was the ability to cast really strong, lightweight metals really thin, right? So this driver is 460 cc. The crown on it is made of, you know, lightweight, very strong titanium. It's about $3 bills thick, right? That one there is a solid piece of laminated maple with a metal sole plate. And so just the ability to move the mass around and make it more forgiving has been huge. And that technology, you know, Carsten pioneered investment casting for irons. The next leap forward in that was really going to, this is centrifugal casting, where you cast it, spin it at the same time, and you can get really thin. We can get some really exotic alloys in there. That would be a huge leap forward.
Yeah, manufacturing's changed a ton. So if money was no object and the tech was available, what would you do differently, say, than what the capabilities are right now of what you had to use to make the G430?
That's a good question. I mean, we're throwing most of what we know at this right now, but probably what we would do more of is blending exotic different materials together. So very heavy, dense materials paired with very light materials, and exotic ways to join them without having to put mass where we don't want it. So that's been one of the big evolutions, is going from single material, you know, all titanium, all steel, all laminated maple. Yes. And optimizing for a single material to using multiple materials. You know, this driver alone has, like, I think 6 different materials in the head. You've got 2 different titanium compounds. We've got carbon fiber on the LST. We've got this, you know, very dense tungsten weight. But pushing the boundaries more of that, of really putting the mass exactly where you want. That's probably one big thing. The other would be just to be able to manufacture more exotic shapes, you know. So and things like additive manufacturing is starting to bring more of that stuff into the mainstream. Those would be the biggest things.
Yeah, okay. And then how about the moment of inertia? So that's really just the forgiveness. It's measured in grams per centimeter squared. Your older drivers, like the maple driver here, might be somewhere between 2 and 3,000 grams per centimeter squared, whereas now you're getting up into closer to, say, 5,500 grams per centimeter squared on the max driver there. Where do you see that kind of plateauing, where there's really no reason to go much higher than a certain number?
Well, 5,900 would be the spot. That's the USGA limit on moment of inertia, and so we're very close to that on this club. One thing we can do, we're not close to the limit on moment of inertia in the opposite axis. So we traditionally measure moment of inertia in a kind of heel-toe axis, basically on a heel and toe miss-hits. And that, with the shape of the club, that's the one that's pretty close to the limit. There is room to increase the moment of inertia in the other direction, the high-low direction, and we're not as close to the limit on that, so we can keep pushing moment of inertia there. But yeah, that's kind of the nature of these things. We get to a USGA limit in one area, and then we start attacking another area, and keep looking for, you know, whether it's aerodynamics, whether it's center of mass, whether it's, you know, optimizing curvature of the face to better fit all golfers. So there's there's other avenues we'd attack.
Yeah, I've asked that question mainly because I saw maybe even last year some drivers were much higher MOI than they were this year. And I didn't know if you saw that kind of trend continuing, or maybe settling in on an XY, or sorry, a heel toe MOI that's closer to 5,000 or 4,500 because you can get a little more ball speed that way, or if you saw a trend of trying to increase the MOI heel to toe but still keep the ball speed super fast.
I mean, all things being equal, more moment of inertia is always a good thing. It's really just what are you trading off in the design. So for two drivers that are identical in all other aspects, a higher moment of inertia is always going to be better than a lower, but what design decisions did you have to make to get there? And so that's, you know, for us, we have our own knowledge, our own manufacturing. Our competitors would have their own knowledge trade-offs and their own manufacturing. So everyone gets there in a different way, but moment of inertia is always going to help you. The real question is, did I have to give up something else, and what am I doing to increase ball speed?
Yeah, that's the ball speed trade-off for sure. I think that's why you've seen some manufacturers go down. How about focal here? We've got this up in the background. Has this helped you at all, and you see this being a useful tool in the future of golf technology?
This has been huge. I think in my time at Ping, and I've been with the company 17 years now, the biggest leaps forward in terms of technology have been, we're in the data age now, and being able to capture way more data than we ever used to. You know, my first year at Ping, we had our first TrackMan system, where we had a radar, we're able to measure things on the range. Well, our company now owns hundreds of TrackMans and quad systems and cameras and radar and you name it. And the motion capture is kind of the top of that, the pinnacle of that, which is super high-speed cameras. We put these little markers on the club. We measure the whole swing. We'll get like 1,000 data points per swing. And the big thing is being able to measure everything from address up to transition. What are you doing, to change the direction of the club? How are you pulling across the shaft, along the shaft, and everything down to delivery of an impact. And so we've been able to understand a lot more about how golfers swing the club from that system. And if you understand more about the inputs, you can optimize the outputs.
Yeah, same thing in golf instruction. Measuring a swing has changed so much, from how tall are you, how long are your arms, all the way down to what we use in every lesson, OptiMotion, to measure joint kinematics and of just everything that you can.
Yeah.
So it sounds like the same sort of advantage is really starting to trickle down more and more into the club fitting space. So that's super cool. Technology is just making golf easier.
Yeah, and just like in instruction, sometimes they were using it to measure things that we kind of knew, but we're able to measure them more accurately. Sometimes you get surprises, and what you thought you knew was actually the total opposite. Those are the really exciting things to a scientist. Hey, we thought we had this figured out, and we totally don't, and that's exciting, so let's go figure it out.
Yeah, no, you sound like a real scientist. That's super refreshing for sure. And in golf instruction, I mean, it's super important for everybody to get a club fitting, to try the latest gear, because you're always improving that. Same thing goes for golf lessons. If you haven't taken one in 10 years, you probably should, because the landscape has changed a lot. The tech is very practical. We're just using cameras to get better. Sounds like you're doing a lot of the same thing. Has there been anything super interesting that's come out of Focal from like the shaft development space?
Yeah, I mean, I think there's been a ton. Boiling it down is a tricky thing, but we've done a lot to look at the effect of where you place mass on the shaft and what that does to a swing, and why some golfers, we put a different shaft in their hands and they swing completely different, and other golfers swing the same no matter what we give them. And understanding that we can classify golfers in these different ways helps us design shafts, but then it also helps us with the fitting process too. Okay, if I know more about you as a golfer, if I put a stiffer flex shaft in your hand, then it lowers the ball flight. You just move your hands back to get the ball flight back up again. Well, we didn't really achieve anything. Whereas maybe for me, it's the opposite, and I just swing the same and get the lower ball flight.
Right.
So that stuff is fascinating. It shows how much the human can never be taken out of the golf swing.
Yeah, so that's interesting. Are you thinking more towards better players who are accustomed to seeing a particular ball flight, and when shots start coming out a little bit lower, they just adjust to accommodate for the ball flight they're used to seeing?
It's kind of a mixed bag, but it's almost like half of golfers adjust that way and half don't. And,
half just keep
and
the
sort of,
variables the same.
and then everyone adjusts eventually, but do you have this natural inclination to adjust straight away?
Yeah.
Or do you kind of, hey, I'll give you that club back and give you one that works properly?
That's interesting. Okay, so Focal, stop me if I say anything incorrect. It's a homegrown system Is it still using Vicon cameras?
We're using Vicon cameras. We're using kind of their latest Vantage cameras, and then actually transitioning to the new Valkyrie cameras.
Right.
FOCAL stands for Fast Optical Capture Analysis Lab.
Do you think you'd ever sell a focal system back to the folks at Fujikura who helped you so much with the Enzo?
Yeah, I think we'd be very open to it. I mean, Fujikura developed that first Enzo system. We've got a ton of value and use out of it. You know, having these partnerships with companies like Fujikura is really helpful for everyone. So.
Yeah. No, that's super cool. That's great that you've gotten so much runway out of that Enzo system, and now you've built your own. So what else? What's coming next in the? I mean, I'd ask you what your next driver is going to be called, but I don't think you'll tell me, at least while the cameras are rolling. But what's new in driver tech that you think will be coming in the next handful of years?
I mean, I think as we've talked about, it is, you know, continuing to push the boundaries on materials. What exotic materials can we use? Can we further optimize? You know, even things like changing the formulations of our titanium alloys. You know, we're doing a lot pushing the boundaries on materials. The manufacturing side, you know, can we blend these materials together? The out-of-the-box stuff, I genuinely don't know. You know, is there a better way to put a shaft together? You know, golf shafts have been done the same way pretty much for the last 30 years. You know, there must be some completely different ways. I can't tell you about that right now.
Well, hey, I appreciate the little bit of insight into some R&D. I'd suggest heel-toe balance as well.
I like it.
You should do that.
It seems like a good idea.
All right, well, let's do this again next year, and we'll talk more about the new stuff you have. Thanks.
Cheers.